Okay, so we are starting Unit 11. This is our 2D and 3D shapes. 3D figures is really what we're going to focus on. The Explore and Reason talks about what is a cross-section, so I'm going to go into details on that a little bit later, but you can always view the Explore and Reason on your ebook. It'll be located in your module. So let's go back to thinking about what is a face, a vertex, or an edge when you have a 3D shape. We call 2D shapes polygons, but 3D shapes are polyhedrons. You'll notice the end of the word is a little different. A face is just known as a flat surface. So it's the flat sides of your 3D shapes. A vertex or vertices are commonly known as the corners of a 3D shape, and the edges are where two faces meet. Or it's the line segments you see. So in this picture we could say, you'll see up here they said this is an edge. It's the line segment where the two sides would meet at. So also, this is a little review from last semester. We came up with the names of the polygons, the flat 2D surfaces. A three-sided figure is just called a triangle. We spent a lot of time doing four-sided figures like square, rectangle, trapezoid, but in general, we just call them quadrilaterals. We'll want you to be specific when saying the cross sections, but for right now, that's just what we call a four-sided figure. A five-sided, it's called a pentagon. 6 sides is hexagon. 7 is heptagon, H-E-P-T-A-G-O-N. 8 side, octagon. 9 is called nonagon. It's not used very much. 10, we use this one, decagon, like a decade, decagon. And 12 is called dodecagon. So below, we're going to be talking about these shapes. These are all different types of prisms. Prisms have rectangular sides, and then you have your bases. They're wanting you to count the number of faces, vertices, and edges you see. So remember, this is called a triangular prism. In that picture, the number of faces would be how many flat sides do you see? So if you could imagine all the flat sides, we could say this is 1, we'd have 2, 3, 4, and 5. So we'd have 5 faces on that. Okay, vertices are how many corners do you see? So you can draw the corners in there or whatever, but here would be 1, 2, 3, 4, 5, 6. So for vertices, all the corners would be 6. And then edges represents the lines that you see. So how many different line segments do we see in this picture? We connect these 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have 9 lines. So that's how you fill in this table. We're going to go through each shape and try and count how many faces, vertices, and edges you see. So again, you can count them. A rectangular prism. This is called a rectangle up here, so that's a rectangular prism. It has 6 sides or 6 faces. Vertices are the corners. You count all your corners. That's 4, 5, 6, 7, 8. So we have 8 vertices, and then we would count all the different lines that you see. So there are 12 lines total. So I'm going to go ahead and fill in the rest of this table. If you were doing this on your own, then you would, again, go around each shape A pentagonal prism has a pentagon base. It has 7 faces. It has 10 vertices. And it has 15 edges or lines. The last one's called a hexagonal prism because it's got a hexagon shape. It has 8 faces or sides. It has 12 vertices. And it has 18 edges or lines. We're trying to see if we can find a pattern in these numbers. It says right here, do we notice any patterns? Well, I definitely noticed a pattern vertically. Like, for instance, in faces, it went up 1, 5, 6, 7, 8. In vertices, it went up 2 every time. When I add a face, I added 2 more vertices. With edges, every time I added a face, I went up 3 more. So going down, I could see a pattern, but they're looking for a pattern going across. And they're trying to find the pattern related to the faces and vertices. And how does that apply to the edges? So the faces plus the vertices, that doesn't equal because 5 plus 6 is not 9. Look for a pattern. You have the edges plus how many? 5 plus 6 is 11. So if I have 9 here, I would need to add 2. Let's see if that works on the next line. The next line says 6 plus 8. Does that equal 12 plus 2? So that would be 14 equals 14. So yes, that one would work. Okay, so the formula that we just discovered is called Euler's formula. Euler's formula is right here. This is F plus V equals E plus 2. These represent the faces, the vertices, and edges. This is going to be a test question to fill in the blanks. For any polyhedron, that means a 3D shape, the sum of the number of faces and vertices is equal to the number of edges plus 2. And you saw from our last table, it worked every time. So this is a test question to fill in the blanks, and over on the right is our formula we're going to use. To make a polyhedron-shaped game pieces using a 3D printer, Juanita enters the number of faces, edges, and vertices into the program. If she wants a game piece with, we have 20 faces and 30 edges, we want to figure out how many vertices do we need. So we're looking for V in the equation. So I'll write down the equation. We have F plus V equals E plus 2. These are just variables to represent those things. So where we see faces, I'm going to put 20. How many vertices, I don't know, so let's keep that a V. Edges was 30, and then it's always plus 2. So if you simplify this, we would have 20 plus V equals, that's 32. Kind of got small here, but if you have that equation to solve for V, to find the number of vertices, the opposite of 20 here, we would have to subtract the 20 to the other side. So we would be left as our answer of V equals 32 minus 20 is 12. So the number of vertices she would need to put into the program is 20 faces, 30 edges, and 12 vertices. The next one, instead of having you solve for one of the faces, edges, or vertices, it has you go ahead and check to see if these work. When we get the homework today, these columns names didn't show up. So you'll have to fill in those words at the top of your homework today, but I put them in the same order as the paper. So up here, I'm going to write down the formula. Faces plus vertices equals edges plus 2. So if I just write these numbers in for 12 plus 20 does that equal 30 plus 2? So the way you would do that is you want to see if they're equal. So these are the numbers you add together, and you want to see if it equals this answer plus 2. So let's see. 32 equals 32. So I'm going to put an X here and say, yes, those were equal. And you just do that for each one. So the next row would be 4 plus 5 equals 8 plus 2. Let's see, are those things equal? 9 equals 10. So that is not true. I'll put no for that one. Okay, I kind of ran out of my room in my box, so I'm going to do the last one in a different color. 15 plus 20. Does that equal 33 plus 2? Again, I'm just doing the bottom row here. 15 plus 20 is 35. And 33 plus 2 is 35. So yes, that one worked. All right, the last thing we're going to do, we're going to switch things to cross sections here. A cross section means when you cut something in half, what is the 2D shape formed at the cut? So these are 3D objects. It says specifically this one's called the octahedron. Plane M and plane N intersect the octahedron. What is the shape of the cross section? So if you think about when, if you ever cut an orange in half, an orange is a sphere, completely a circle. If you cut it in half and you look at where the cut is, you would see a circle. The same thing works here. If we cut this thing in half going straight down, the idea is if we cut it, the face that you would see is this triangle. We would see a triangle shape where that piece of paper is if we cut it off. So plane M, we would see a triangle. It's what 2D shape do you see if you cut it? So not the whole shape, but what 2D surface would you see? Plane N, if we cut it horizontally, if you cut the top off and you look down at it, we would see a square. So you're looking for a 2D answer there. Let's try this one. If I cut the shape at the cross section below, they cut it off here, right? They're moving that paper to the side, they cut it off. What shape would be on top? Like when you're looking down, we would see this shape here. So if you cut off that top or the bottom and you looked at where you cut it, we would see a pentagon. Now it says, what if you cut it the other way? What if you cut it vertically? It says perpendicular to the base, but that just means if you cut it the other direction, say if I cut straight down, if you cut straight down, cut that front off from the back, we would see a triangle. All right, the last thing we're going to talk about today is rotation. So that was cross sections, what 2D shape is formed. The last one is talking about rotating to form a 3D figure. So if you have a 2D figure that's rotated around an axis, it forms a 3D figure. In this particular example below is a rectangle. And it's rotated around the y-axis. Let's see what happens. If I just flip it to the other side without spinning it, I would get a bigger rectangle. When you spin something, it creates a circular motion of the object. So as I spin this object, it's going to create a cylinder. It's kind of like a fan, a rectangle blades, and this is a 2D example, but if you take a rectangular fan blades and you spin them really fast, it gives the illusion it spins into a circle. Same thing here, if we take this rectangle and spin it really fast around in a circle, it's going to give this illusion that we have a cylinder. So the idea on this one, we're going to do the same thing. I'm going to take this 2D triangle and I'm going to spin it around the other side. When I start to spin, it creates this circular motion, which maybe you can tell what shape that is. That would be a cone. If you take a half circle and spin it, now half circles are a little hard to do because circles are just hard to draw perfect. But if you took that and spin it around, so I'm going to still do the same kind of spinning, going around in the circle around that line. When you spin that half circle, it forms a sphere. And the last one's still spinning around this vertical line. So I'm going to go around and around. Didn't quite make it all the way. That is called a hemisphere. Hence, you probably have heard that word in about the world. We have the northern hemisphere and southern hemisphere. So if you spin a flat surface, a 2D shape, it will spin fast enough to create the illusion of the 3D shape.